Here are the solutions for page 5 of the mock final of Math 10. We will multiply a column matrix M with the matrix A below. Which of the multiplications is possible? A times M or M times A? Remember, these are matrices. Okay, so A is a square matrix, a 2 by 2 square matrix, and M is a what we call a column matrix. So remember that a square matrix, we can write it as 2 rows by 2 columns, 2 rows by 2 columns, right? And then we can write the column matrix as a 1 row times 2 columns, okay? And, or I'm sorry, 2 rows times 1 column, right? Okay. And how do we check to see if we can multiply these together? Well, one of the most convenient ways is just to write them side by side. Okay, so write down the dimensions side by side. And if the middle two numbers match, if the rows of the second matrix is equal to the number of columns of the first matrix, then you can multiply them. It doesn't matter if these two numbers are the same. Okay, actually, these two numbers are going to tell you what is the size of the resulting matrix. So these green numbers, which is 2 by 1, is going to tell you the size of the resulting matrix. Okay? So which one is possible? A times M or M times A? Well, what is possible would be A times M. Okay? If you put the square matrix on the left and the column matrix on the right, then you can multiply them. See what happens if you reverse them. If you put the column matrix first, and then you put the square matrix second, you can see that the middle two numbers no longer match. Okay? So the middle two numbers must match. Or another way you could say it is the first matrix number of columns must equal the second matrix number of rows. Okay. Now it says to actually multiply matrix A with matrix M. So we're going to do that. Okay. So here's matrix A, and here's matrix M, and we're going to multiply them. So we multiply them by multiplying that row times that column, right? So we're going to have 0 times 1 plus 1 times 2, which gives you 2. And then we're going to have 1 times 0, which is the second row of the first matrix. We're going to multiply it times 1, 2. We're going to get 1 times 1 plus 0 times 2, which is 1. So you can see the result of multiplying from matrix A with matrix M gives you another column matrix, except this one, the numbers are reversed. Okay? I'm going to show you an alternative way to do a multiplication between B and M. Okay, if you have B and M, let's see, write your B matrix here on the side, and then write your resulting matrix here. It's going to be a column matrix. And then write your M matrix here. Okay, and if you do it like this, what's kind of cool about it is it's easy to see which rows and columns you multiply together to get this number and to get this number, because they kind of intersect each other, right? So if you multiply these two together, then you get this number. So again, 1 times 1 is 1, 0 times 2 is 0, so you put 1 here. And then now we're going to do this one and this one. So we're going to do 0 times 1 is 0, and negative 1 times 2 is negative 2. So our resulting matrix here is 1, negative 2. That's in the case of B. And then finally we have the case of C. I'll do C also this way just so you can see how it works with C. Okay, and so first I'm going to multiply negative 1 times 1, which is negative 1, 0 times 2, which is 0. I'm going to add them together. I get negative 1. Then I'm going to take 0 times 1 and I get 0, and I multiply 1 times 2 and I get 2, and I add those together and I get 2. Okay, so very interesting. Do you see how multiplying the column matrix 1, 1, 2, you get different combinations of 1s and 2s in different orders or with negative signs. Okay, so that's very interesting. Okay, now we're going to go to 4C. If the column matrix M represents the coordinates of the point M, 1, 2, then specify what type of reflection is performed when multiplying by each matrix A, B, and C. Okay, let's draw a little picture. So we're going to draw a grid, and we're going to draw the original point 1, 2. It's right there, right? What happens if you multiply by matrix A? When you multiply by matrix A, you get another column matrix, which is 2, 1 instead of 1, 2. If you're going to graph that point, it would be here. Okay? So, yeah, it says multiplying the matrix by this should be matrix A. Oops, sorry. Multiplying matrix A by column matrix M reflects the coordinates of M about and then what axis are you multiplying, or are you rotating about, or reflecting about? And it would be this diagonal axis here. Do you remember what the equation for that line is? It's y equals x. Okay? Now let's graph what happens when we multiply by the B matrix. Okay? So we start out again with 1, 2. It's right there. And then it is transformed to 1, -2, which is right down here. So this is also a reflection, but this reflection happens to rotate about this line here, which is the x-axis. Okay? So multiplying matrix B by the column matrix M reflects the coordinates of M about the x-axis. Okay? Multiplying matrix C by the column matrix M reflects the coordinates of M about the, and let's figure out what this one is. So we start out at 1, 2, and then we're going to get the resulting matrix of -1, 2. So it would be right there. So you can see that here we are reflecting about the y-axis, right? The y-axis. Okay. Next one. Sketch the unit circle and the point N on the unit circle, which is at an angle of -60 degrees relative to the positive x-axis. Okay. So I'm going to draw a unit circle, and I'm going to draw a point N on the unit circle, and the point N is at an angle of -60 degrees relative to the positive x-axis. Remember, the positive x-axis is this side of the x-axis, okay? And the angle is -60 degrees relative to that. So it's kind of like that, right? So this angle here would be 60 degrees. Actually, it's -60 degrees, right? -60 degrees means going around the circle clockwise, okay? Counterclockwise would be positive. Clockwise is a negative angle. Okay, so we just sketched it, and we do need to label the point as N. Okay. What is the reference angle for the angle -60? Okay, remember reference angles? Reference angles are angles between 0 and 90 degrees, and they measure between the line of the angle to the closest x-axis. So in this case, the angle between this point and the closest x-axis would be this triangle here, this angle here, okay? And to make it a positive angle between 0 and 90, we're just going to flip it up here so that we can see it here, and then it's a little easier to see that this is positive 60 degrees. Okay? So the reference angle is going to be positive 60 degrees. Okay? And then it says, give the cosine and sine for the reference angle. Okay, there's a couple ways you can do this. One is use the calculator. So if we use the calculator, we'll say, what is the cosine of 60? And, we need to make sure that we are in degree mode, right? So first we're going to go to the mode button, which is here. And then we need to go down and change it to degrees. And then we quit. And then we say, okay, now I want to know what the cosine of 60 is. It's 0.5, okay? So the cosine of 60 is 0.5, according to the calculator. The sine of 60 degrees is equal to 0.866 according to the calculator. Okay. The other way you could do it is you could use special triangles. So if you have the cosine of 60, then you know that this is a 30, 60, 90 triangle, and the proportions of this triangle are 1, 1/2, and square root of 3 over 2. So we know that the cosine of this would be the adjacent divided by the hypotenuse, which is 1/2, and the sine of this would be the opposite divided by the hypotenuse, which would be square root of 3 over 2 divided by 1, which is just square root of 3 over 2. And square root of 3 over 2 is 0.866, and 1/2 is 0.5. Okay? All right. Moving on to 5c. So 5c says, what are the cosine and sine for the original angle -60, and how do these values correspond to the coordinates of the point N of the unit circle? Okay, so so we know that the cosine of positive 60 is 1/2, and the sine of positive 60 is 0.866, or square root of 3 over 2. What about for the original angle, which points down? Okay, remember that the x-coordinate and the y-coordinate for this angle here are related to the cosine and sine of the angle. Okay, and so we know this is a 30, 60, 90 triangle too. And we know that this y-coordinate here is going to be 0.866, right? Except it's going to be negative 0.866 because it's going down. What about the x-coordinate here? It's going to be positive 0.5 because it's pointing to the right. Okay? So actually, from this drawing, we know that the cosine of the angle, which is cosine of negative 60 degrees, is equal to 0.5. And we know that the sine of negative 60 degrees is equal to 0.866, or square root of 3 over 2. And we know that these are actually related to the x-coordinate and the y-coordinate. Okay, so that's the relationship. This is how do these values correspond to the coordinates of point N of the unit circle. That's how they correspond. Okay. The column matrix below represents the coordinates of the point 1, 2. Create a rotational matrix which would rotate the point M by negative 60 degrees and then perform the multiplication that finds the rotated point coordinates M dash, okay, or M prime. So this is the original M, and we're going to make a matrix that's going to multiply this column matrix, and it's going to give us points which rotate the points 1, 2 by negative 60 degrees. Now this is something that's good to put in your formula sheet. A rotational matrix can be written in this form: cosine of theta, sine of theta, negative sine of theta. Okay, and what's theta? Theta is the angle you're going to rotate by, and in this case it's negative 60 degrees, right? So what we're going to do is we're going to make a rotational matrix where it's the cosine of negative 60 degrees. It's the sine of negative 60 degrees. It's the negative sine of negative 60 degrees. And it's the cosine of negative 60 degrees again. Okay, so if we do that, then we're going to have a rotational matrix which we can multiply times 1, 2, the matrix here. And then that will give us a new matrix, which is that point 1, 2 rotated by negative 60 degrees. So let's rewrite that the cosine of negative 60 degrees, we're going to go to the previous problem, and we're going to see that 0.5. And the sine of negative 60 degrees is 0.866. Actually, oh, I forgot, it's negative 0.866, right? So this is going to be negative 0.866, and actually negative sine is positive 0.866. Okay? Okay. Now it says to do the multiplication that finds the rotated coordinates. So I'm going to do that. I'm going to take my new matrix, which is this matrix here. You can do it with square root of 3 over 2 if you want. Okay, and I'm going to multiply it times the matrix 1, 2. Okay, and so I'm going to multiply this times this, and that's going to be 0.5 plus 2 times 0.866. I'm going to have to do that on the calculator. 0.5 plus 2 times 0.866. $2.23. Oops. So the first one's going to be 2.23. The next one is going to be negative 0.866 times 1, negative 0.866 times 1, plus 2 times 0.5, which is plus 1, which gives me 0.134. Okay. Now, if I drew this, I'm going to draw the original point, which is 1, 2. I'm going to put it there. And then I'm going to draw the new point, which is 2.23 and 1.34, like right there. Okay? So it's kind of hard to see if this is really right or not, especially because I'm not even drawing with grid paper. But basically, what I've done is I've taken the red point and I have rotated negative 60 degrees, and the way I get the new point is I do this matrix multiplication with this secret new matrix that I just made using this formula. Okay, so definitely write that formula down on your formula sheet. Okay, let's finish up here. Angle X is formed by the line connecting the origin to point P on the unit circle and the positive x-axis. Okay. So we're going to draw a unit circle again, and we are going to put point P on it. And where are we going to put point P? Well, I'm going to put it here, and you're going to find out why in a second. Okay. Angle X is formed by the line connecting the origin to point P, origin's here, okay, and the positive x-axis, which we know is here, right? So this is the angle. The angle is called X, but we don't know exactly how big it is, okay? And then what we do know about angle X is the cosine of X is negative 0.574, and the sine of X is equal to 0.819. Okay, in which quadrant does the angle lie? Well, the quadrant lies in quadrant 2. Okay, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, we normally write them with Roman numerals. So it says sketch it in the unit circle. Not only did I sketch it in the unit circle, but I also labeled the quadrant 2. The reason why I know that point P is in quadrant 2 is because remember that the cosine and the sine of the angle which points to P are going to correlate with the x-coordinate and the y-coordinate of the point P. So if we know that the x-coordinate of point P is negative and we know the y-coordinate of point P is positive, then we know it's in we know it's in this sector, right? Or this quadrant. Okay. What is the reference angle for X, and explain how you calculate it? Okay. Well, the reference angle for X is going to be the angle for this triangle here, but a positive version of that angle. Okay. So here, like, let's see, we have the angle X, right? And we don't know what the angle X is yet, but we're going to figure it out. And then what's left over, okay, so there's angle X like that, right? What's left over here in this triangle, this green triangle, I'm going to draw green here just like I did above so you don't get confused. This triangle here, it has an angle right there, which is like the leftover of X. Leftover from what? Well, it's left over from 180 degrees, right? So I could take 180 degrees, because that's like, you know, this flat angle, and I could subtract X, and that would give me my reference angle for X, right? Does that make sense? The reference angle plus X is equal to 180 degrees, okay? So the way I calculate it is I do this formula, 180 degrees minus X, and that equals the reference angle. Okay, so that's my explanation. I could write it out in words, but I write really messy with this pen, even more messy than usual. What is the angle X? Well, I can figure out the angle of X because I know that the cosine is negative 0.574 and the sine is 0.819. I could use either one of those angles to probably figure it out. Let's try. So I have that the cosine of X is equal to negative 0.574. let's see what the calculator does with that. So I'm going to say, okay, calculator, inverse cosine of negative 0.574, and it tells me 125 degrees. Now, the angle 125 degrees happens to be in quadrant 2. So that answer really makes sense. Okay? Now, if I find the inverse sine of 0.819, it's going to give me an angle that is not in quadrant 2. It's going to give me the angle 54.98 or 55 degrees, right? So if I do the inverse sine of 0.819, it gives me just 55 degrees instead of 125 degrees. Well, it turns out that the reason why that happens is because the sine of this angle with an angle of 55 degrees and the sine of this angle, which has an angle of 125 degrees, both have the same sign. They both have the same y coordinate, so they both have the same sign. So that could be confusing, right? So really, to know what x is, you need to know both the cosine and the sine, and they gave us both in this case. They told us that the cosine is negative, they told us that the sine is positive, so that means that we're talking about this angle here, 125 degrees, and not the angle 55 degrees. Okay? And let's maybe finish up the one last part for this one. Confirm using a trigonometric identity that the point P lies in the unit circle. Okay, so we know that the point P has the coordinates negative 0.574 and the other one is 0.819, right? How can we confirm that that is really on the unit circle? What if we didn't trust whoever gave us this data? How do we confirm that this point is on the unit circle? Well, remember Pythagorean's theorem, right? This is a right triangle. We know that the hypotenuse is 1 because it's a unit circle. We can use Pythagorean's theorem to confirm this. Actually, there's a special version of Pythagorean's theorem, which is sine squared plus cosine squared theta equals 1. Definitely put this on your formula sheet, where you can actually confirm this by multiplying and substituting and multiplying everything together. So let's try that. So we have 0.819 squared plus negative 0.574, and you notice that if you put a negative number and you square it, you're just going to get a positive number anyway. Okay, and I got 1.000. It turns out that it's equal to 1. Okay, it's not exactly 1 because we're only putting 3 significant figures. You need to put a lot more to get it to be more close to 1. Okay, so we have proven it. We proved it by using this trigonometric identity. Okay, and the rest I'll put in the next video because this one got way too long.